Imagine a massive object forged in the fires of a distant star system, hurtling through the void of interstellar space at speeds unimaginable. Unlike the asteroids and comets that orbit our sun, this intruder originates from beyond our solar system, a cosmic wanderer with no allegiance to our celestial neighborhood. Now picture it on a collision course with Earth. This is indeed the plot of a science fiction blockbuster. It is a scenario scientists are actively studying. Interstellar objects like the now famous Oumuamua and 2I Borisov have revealed a new frontier of potential cosmic threats. These objects, traveling at breakneck speeds, challenge our understanding of space and raise a chilling question. Could one of these interstellar visitors strike Earth? And what would it mean for humanity? In this exploration, we'll dive into the science of interstellar objects, their origins, trajectories, and the very real possibility of an impact. From groundbreaking discoveries to the cutting-edge technology designed to detect these cosmic bullets, we'll uncover why these objects are far more than a scientific curiosity. They were a wake-up call for planetary defense. Interstellar objects are celestial bodies, comets, asteroids, or even fragments of unknown composition that originate outside our solar system. Unlike the familiar asteroids of the Kuiper Belt or comets from the Oort cloud, these objects have traveled vast distances across the galaxy, ejected from their home star systems by gravitational interactions or cataclysmic events. They roam the interstellar medium, unbound by the gravitational pull of any single star, until they happen to pass through a system like ours. The discovery of Oumuamua in 2017 marked a historic moment in astronomy. Detected by the Pan-STARRS telescope in Hawaii, this cigar-shaped object was moving at an astonishing 196,000 miles per hour, far too fast to be bound to our sun's gravity. Its unusual shape, lack of a cometary tail, and trajectory confirmed it as the first known interstellar object to visit our solar system. 2 years later, in 2019, amateur astronomer Gennady Borisov discovered 2I Borisov, a more comet-like interstellar visitor with a visible tail of gas and dust. These discoveries shattered the notion that our solar system is an isolated bubble, proving that objects from distant stars can, and do, pass through. But what makes these objects so intriguing is also what makes them potentially dangerous. Their high speeds, unpredictable trajectories, and origins from unknown systems mean they don't follow the familiar orbital paths of solar system objects. This unpredictability complicates efforts to detect and track them, raising the stakes for planetary defense. The idea of an interstellar object striking Earth might sound like a remote possibility, but the consequences of such an event could be catastrophic. To understand the threat, we need to consider 3 key factors: speed, size, and unpredictability. Interstellar objects travel at velocities far exceeding those of typical near-Earth asteroids. Interstellar objects vary in size from small fragments to massive bodies. Oumuamua was estimated to be 101,000 meters long, while 2I Borisov was roughly 0.41 kilometer in diameter. While these objects were not on a collision course with Earth, a larger interstellar object, say 10 kilometers across, like the asteroid that wiped out the dinosaurs, could cause an extinction-level event. Even smaller objects, if traveling fast enough, could release energy equivalent to millions of tons of TNT upon impact, leveling cities or triggering tsunamis. Unlike near-Earth asteroids, which follow predictable orbits, interstellar objects come from outside our solar system, making their trajectories difficult to anticipate. They can approach from any direction, at any angle, and at speeds that defy conventional tracking methods. Current detection systems, like NASA's Near-Earth Object Observations Program, are optimized for objects within our solar system. Interstellar objects, with their high velocities and non-standard paths, often go unnoticed until they're already passing through. Oumuamua, for instance, was only spotted after it had already made its closest approach to the Sun. Detecting interstellar objects before they reach Earth is a monumental challenge, but scientists are rising to the occasion with advanced technology and innovative strategies. Here's how the global scientific community is tackling the problem. Ground-based telescopes like Pan-STARRS and the upcoming Vera C. Rubin Observatory are critical for spotting interstellar objects. The Rubin Observatory's Legacy Survey of Space and Time, LSST, set to begin in 2025, will scan the entire visible sky every few nights, dramatically increasing our ability to detect fast-moving objects. Its wide field of view and deep imaging capabilities make it ideal for catching interstellar visitors early. Space-based telescopes, such as the planned NEO Surveyor mission, will complement ground-based efforts by observing in infrared, which can detect objects that are too faint or dark to be seen in visible light. These systems are designed to identify objects approaching from unusual angles, a key advantage for tracking interstellar threats. Once detected, an object's trajectory must be calculated to determine if it poses a threat. This is no easy task for interstellar objects, as their paths are influenced by complex gravitational interactions with the Sun and planets. Scientists use advanced computational models to predict these trajectories, but the high speeds and short observation windows of interstellar objects make precise calculations difficult. Machine learning algorithms are now being developed to improve trajectory predictions, allowing for faster and more accurate assessments of potential impact risks. If an interstellar object were found to be on a collision course with Earth, what could we do? Planetary defense strategies, such as those developed by NASA's Planetary Defense Coordination Office, focus on deflection or disruption. The 2022 DART, Double Asteroid Redirection Test, mission successfully demonstrated that a kinetic impactor could alter an asteroid's trajectory, a technique that could theoretically work on an interstellar object if detected early enough. Other proposed methods include laser ablation, where a laser vaporizes part of the object to change its path, or even nuclear deflection for larger threats. However, these strategies require time, potentially years, to implement. The high speed and late detection of interstellar objects could leave humanity with mere weeks or days to respond, underscoring the need for early warning systems. While the discovery of Oumuamua and 2I Borisov suggests that interstellar objects pass through our solar system more frequently than once thought, the odds of a direct impact remain low. Scientists estimate that 1 or 2 interstellar objects pass through the inner solar system each year. But the vastness of space means collisions are rare. Most interstellar objects are small, and Earth's atmosphere would burn up objects less than 50 meters in diameter, preventing surface impacts. However, the stakes are high enough that even a small probability warrants attention. A 2018 study estimated that an interstellar object the size of Oumuamua could strike Earth once every 100 million years or so. While this seems reassuring, the unpredictability of these objects means we can't rely on statistical comfort alone. A single large impact could reshape life on Earth as the Chicxulub asteroid did 66 million years ago. Beyond their potential as threats, interstellar objects offer a unique opportunity to learn about the universe. Each object is a time capsule, carrying clues about the chemistry, geology, and history of distant star systems. By studying their composition, through spectroscopy or, in the future, sample return missions, scientists can piece together the processes that form planets and stars across the galaxy. Moreover, the study of interstellar objects pushes the boundaries of astronomical technology. The same tools developed to detect and track these objects can be used to monitor near-Earth asteroids, improving our overall planetary defense capabilities. The Vera C. Rubin Observatory, for example, is expected to discover thousands of new asteroids in addition to potential interstellar visitors. The discovery of Oumuamua and 2I Borisov has opened our eyes to a new kind of cosmic threat, one that challenges our assumptions about the safety of our planet. While the odds of an interstellar object striking Earth are slim, The potential consequences demand that we take the threat seriously. Advances in telescope technology, trajectory modeling,